Hi everyone. Today we are going to talk about C++ STL algorithms. Um, as we can remember, um, we covered concept of container, which is a subject that holds a sequence of objects. Once you have those containers, iterator become a way to cycle through contents of the container you have created. Algorithms is another important pillar of STL. Um, the definition of algorithm is a collection of functions specifically designed to be applied on a range of elements in the container. Um, so you can apply the algorithms on the vector um, or set or list, for list. Basically, virtually every type of container you can apply some sort of algorithms on them. So if you want to use some existing STL algorithms, you start pound include algorithm at the very beginning of your program. Here is a list of existing algorithms that you can use. The most popular one is sorting, um, and you can also find certain elements in your container. You can insert elements into your container, or delete, or shuffle, or reverse elements in your container. You can also copy and find maximum and minimum element among all elements in the container. And also, you can count elements, and you can find unions between containers, or you can find intersections of containers. Um, and there may be many more algorithms. Here we're going to show you three examples. Um, Here are the files you can find on Dr. Carroll's website. So we're going to switch to Visual Studio. Um, so here is the first program. So here is the first program, which I meant to show you how to use algorithms. Specifically, count is one of the algorithms in the STL library. Count container requires you to pass um, the first iterator and the last iterator, and the value you want, count, and it returns a number of how many times this value appears in your container. And also you need, in this example, you need a vector, and we predefined max as 1,000, largest number as a 10, and this is how we define a random num as a vector of integer, and we use srand to generate a seed to be used as a generator to generate random number. At the beginning, we have 0 elements inside this random nums vector, so the size is 0. 0 is always less than 1,000. So if that's the case, we start pushing a random number modulate by largest number, which is 10. So inside this brackets, the only thing can return is from 0 to 9, since this is a moduli operation. And basically we push 1,000 number into this vector random nums. So once it is exceed 1,000, it will exceed the while loop. So and we also define a random num integer created by a random function moduli by largest number, which is 10. So it will give a random number from 0 to 9. And here is the count algorithm as the definition of the algorithm we can apply to this vector container, which we pass the first iterator by dot begin, and we passed the last iterator by dot end method, and we want to see how many times this random num appeared in this random nums vector, which returns how many occurrences of random number appears in the container. And here it prints out this random number appears how many times, and around the max 1,000 divided by 10, which is 100, which is the average value. The second part of the program start with creating the character array. Consists a series of characters, and the size of this character array by one character array is how many character array inside this array. And we're looking for a specific character S. So this way we can count how many S are in the character array by passing the pointer, the base address of character array, and the ending address of this character array by plus array size, and it will print out S appears 2 times. We can run these programs to see the result. So 0 appears 98 times, which is around 100. S appears 2 times, as we expected. And we can run this again. This time 7 appears 110 times, which also is around 100, as it is expected. We'll close this program, and we are going to run another program. The second program we're going to run is random shuffle. Here is the program. We include algorithms, and also we include DAQ, which is doubly ended queue, and we create this DAQ by template declaration, and we push back the the letters from A to Z, and we call this shuffle function, and it applies on the random letter Q. It takes the beginning iterator and ending iterator. So once this function is applied, the contents of this random letter in this random letter Q is shuffled. So it's not A to Z. It can be any order that is random. And here it prints out shuffled result in the queue. So we are going to see the result. As you can see, those letters are not ordered into A to Z, so it's random, so it is expected. So we're going to show you the next example, which is sort algorithms. So here we also include DAC and algorithm, and we define max as integer 26, and similarly we have random letter DAC container, and we push in 26 letters from A to Z in exceeding order, and we shuffle the container in terms of contents by passing the beginning and end iterator, and we print out the randomized result. And here is how sort algorithm is used. We basically pass in the beginning iterator and ending iterator. So after this operation, the contents in the random letter container is sorted from A to Z, and this part is the way to print out the contents of sorted elements in the random letter. So we will see the result. So as we expected, the first prints out randomized result. After sorting, we have a very nice sorted A to Z characters.